Hi everyone. In this video we're going to look at long division where there's more than one term involved, right? So for example, instead of this being a division just by x, it's a division by x minus 2. We are going to run parallel to how numbers are divided. So we write it in the same fashion. So we start with x squared minus 14x plus 24 and an x minus 2 here. The only difference here is in numbers we just had one term to worry about, but now we've got two. So we're going to deal with them one at a time. I'm going to look at the highest power of x and the highest power of x, and I'm going to see how many times does x go into x squared. So x, actually it's much easier to view this in this manner. Basically, you're trying to find what is x squared over x, and that is x, which means that this number here should be x. So now you have x times x is x squared, but you also have to multiply the second term with x. So you have a negative 2 times x to give you negative 2x. After that, you do the same thing as with numbers. You subtract them. Now when you subtract, you have to be careful that subtracting a negative number makes it positive. So this is a positive number, so this would be minus. This is a negative number, so when you subtract, this is actually a plus. Now x squared minus x squared, that cancels out. Negative 14x plus 2x is negative 12x. And then I bring down the next term, which is plus 24. Now repeat the same process, now this time with x and negative 12x. Negative 12x over x is negative 12, so this must be negative 12. And then I multiply negative 12 with both of these. When I do that, I get negative 12x plus 24. And then, of course, I subtract. When I subtract, the negative becomes a positive and the positive becomes a negative, but they both cancel each other out and I'm left with no remainder. This means that x minus 2 divides x squared minus 14x plus 24, or it means that x minus 2 is a factor of x squared minus 14x plus 24. You can actually even verify by performing the factoring on this polynomial using the split the middle term, and one of them should come out to be x minus 2. Okay, let's look at a second example. Now here, I have this x squared having negative, so I'm going to rearrange it. I'm going to rearrange in decreasing powers of x. So that is going to be rewritten as negative x squared minus 5x plus 4 divided by 3x minus 2. Now because instead of an x I have a 3x here, this might get a little messy. So let's see. Negative x squared minus 5x plus 4 and a 3x plus 2. Now in my first step, I compare these two and I evaluate negative x squared over 3x. Now from our monomial division example, I know this is negative x over 3. So what goes here is negative x over 3. But now I multiply this with everything. So the first one is negative x squared, but the second one is 2 times negative x over 3, or negative 2x over 3. Now I need to subtract these. When I subtract, the negative becomes a positive, negative becomes a positive, these cancel. Then I do this calculation in the scratch here. 2x over 3 minus 5x is 2x minus 15x is negative 13x over 3. So this is negative 13x over 3. I bring down the last term to get a plus 4. Now once again, I compare 3x with this leading term. Negative 13x over 3 divided by 3x becomes negative 13x over 3 times 1 over 3x. The x cancel out and I'm left with negative 13 over 9. So this is negative 13 over 9. And then when I multiply this with both the terms, the first is going to give me negative 13x over 3. That's because that's how we found that number. Now the second one is going to be 2 times this number, which is negative 26 over 9. And now when you subtract, this is a plus and this is a plus. So you end up with 4 plus 26 over 9, which if you take the LCM is going to be 36 plus 26, which is further going to be 62 over 9. So in this case, the quotient is negative x over 3 minus 13 over 9, and the remainder is 62 over 9. So the remainder in this particular example is not 0, which means that this is not perfectly divisible. So in such cases, one of these two things is going to happen. You may end up with a 0, in which case you can draw these two conclusions, or you may end up having some number. Now once you are at the number, you have to stop because you cannot divide 3x by a number. Okay, you cannot divide this number by 3x because then you start getting into terms that are no longer polynomials, right? They become division by x, which is not a polynomial. So that's about it for this video. In the next video, we're going to see what happens if I have to divide by a polynomial which has a degree that is more than 1, right? So these examples, the denominators have degree 1. So what if the denominators have a higher degree? So it turns out the same process works. We just have to be a little careful about how we're doing the process, and it gets a little longer than 2 steps. So that will be covered in the next video. Thank you.